Hey, what's up? It's your old pal, Mr. Cook. We just got done with the first page of the 7.2 extra practice. We're verifying trig identities, and now we're going to do the dreaded back page with 4-star and 5-star problems. So, as always, I'm going to try and do all this in one shot. Let's see if we can get it done without any mistakes. I don't know if it's possible. I don't know. We'll see. All right, so we've got tangent squared minus sine squared, and we're supposed to turn that into tangent squared sine squared. Okay, well, let's see. I mean, I guess I've kind of established this like little standard procedure of turning everything into sines and cosines, unless I see some wacky identity. So I don't know. I mean, I'm not gonna deviate from that path. Let's just kind of keep doing that at first and see if we see something nice that we can do something easy with. All right, here we go. So tangent squared, that's a quotient identity. Let's turn that into sine squared over cosine squared minus sine squared. And, let's get the common denominator here. So I multiply the top and the bottom by cosine squared. So then I end up with sine squared of x minus, and then it'd be sine squared of x cosine squared of x over cosine squared of x. And if you've been in my class the past week, you've kind of seen this step played out. So let's kind of just work with it. And I think we actually might have done this problem in an earlier homework. Oh well, yeah, because it seems all familiar. Sine squared and both of these little terms, I can factor that sine squared out, so I'd get sine squared of x times parentheses, and then this would turn into a 1 minus cosine squared over cosine squared. And then 1 minus cosine squared, that's a Pythagorean identity. So this turns into sine squared of x times sine squared of x over cosine squared of x. And then you already have your sine squared here, and then I just got to turn this into a tangent, and that's pretty easy because this is a quotient identity. So I can just rewrite it as tangent squared of x times sine of x and sine squared of x, and I'm all done with my little proof there. Okay, let's take a look at this one. Let's evaluate it before we look at it, because those look a little bit like identities. So they're not quite there though. See, I have a 1 minus tangent squared, and it's 1 plus, and then it's cotangent minus 1, but this is cotangent plus 1. So they're real close to those identities, but they're not quite there. So I'm going to abandon the identities, not use them, and maybe just do the same kind of crap I've been doing, which is turning everything into sines and cosines and hoping for the best. So let's do the same thing, I guess. So the tangent squared, that's a quotient identity. Same thing with the cotangent. So this turns into 1 minus sine squared over cosine squared. And then it's cosine squared over sine squared minus 1. We're supposed to turn this whole thing into a tangent. Man, let's see what we can do. All right, let's get the common denominator here, I guess. So for this one, it'd be multiplying by cosine squared in the numerator and denominator. So that would turn into cosine squared of x minus sine squared of x over cosine squared of x. And then in the denominator here, I'd do the same thing, find the common denominator, so that multiply the top and the bottom by sine squared. So I'd get cosine squared of x minus sine squared of x over sine squared of x. And even these, that's not exactly the Pythagorean identity. We're subtracting them. So I don't know. I mean, but they are the same here and here. So I'm gonna do the whole multiply by the reciprocal thing. So keep the top part the same, cosine squared of x minus sine squared of x over cosine squared of x times the reciprocal of this. So that'd be sine squared of x. Oh, I see it already, over cosine squared minus sine squared. So the denominator here and the numerator here are identical. So they eliminate each other. So all I'm left with is that sine squared in the top, the cosine squared in the bottom. And that's a quotient identity, and that gets our little answer, tangent squared of x. There we go, good. So this cosine squared ended up being kind of not important at all, just kind of a misdirection to scare off some people, but it wasn't that bad because we didn't even end up using it really other than to cancel it out at the end. Okay, so that's number 9 and number 10. So far, so good with these little 4-star problems. Let's see these 5-star ones and see why they're so challenging potentially. Now, this one, number 11, I know that we probably did that one in the review. I'm pretty sure that we did, but I don't know. Let's just go through the steps on how to do it. Let's do our same random stuff where we do the whole sines and cosines and kind of see where we can go from there. Okay, so tangent, that's a, quotient identity, secant, reciprocal identity. So this turns into sine of x plus, and tangent is sine of x over cosine of x. And then 1 plus, and then secant is 1 over cosine of x. Oh yeah, we totally did this one in class. So a real easy way to solve this is to realize that both of these terms in the numerator have sines in them. So you can factor out the sines. So we get sine of x, and then parentheses, and then it'd be 1 plus 1 over cosine of x. And that should sound familiar because it's like the exact thing, exact denominator there. So if I have that exact same thing in the numerator and denominator, they cancel out, and you're just left with regular old sine of x as your answer. So, that's pretty cool. You can just, factor out the sines. And you can, if you don't believe me that that's what you can do with that, like factoring out the sines, just distribute the sines back in and check it out. Look, sine times 1 is sine. Sine times 1 over cosine is sine over cosine. See, it's the same thing. And what identities do we use? We just use the ones at the beginning, and that's it. That's pretty neat. Well, 5 stars. It's probably just for that one little part right there. Okay, number 12. Let's take a look at this one. Oh, okay, I see what we can do with this one. This is a problem where the identity that you're going to use, this is going to blow your mind. Well, maybe it'll blow your mind. I don't know. I think this is pretty cool. You might think it's kind of stupid, but, whatever. It's the 1 right here. So that 1 is going to be used as an identity. Because, you ever, look at these identities, real closely? Some of them are equal to 1. So, this 1, any 1 is equal to this, expression. Same thing with this 1 is equal to this expression, and this 1 is equal to this expression. This is really neat in these two cases because just like, some of these other problems that have difference of squares, these are difference of squares problems, so they can get factored. So this secant squared minus tangent squared can get factored to look like this: secant of x plus tangent of x times secant of x minus tangent of x. Yeah, it's just difference of squares. So the same can be true for this identity. And the reason that I single out this identity is because if you look, this is one of those little factors from your difference of squares. And this is the other one. So what I'm going to do is use my Pythagorean identity, this one, and I'm going to change this 1 and use the Pythagorean identity to turn this one into, and this is crazy, it's going to be the cosecant squared of x minus the cotangent squared of x. So I'm turning that into this. Isn't that wild? Because then, when I have this expression from this Pythagorean identity, I can factor this so that it looks like this. So that turns into cosecant of x plus cotangent of x times cosecant of x minus cotangent of x, all over the denominator, which is cosecant of x plus cotangent of x. That's messed up, isn't it? It's cool because use that one identity, then this cancels out, and you're left with your answer, that you're looking for, cosecant of x minus cotangent of x. That's brutal. I like that little 5-star problem. Okay, so that's number 12. We've got 2 more of these 5-star problems. So let's see. Oh boy, it looks like probably, I'm going to guess. No, do we want to do the common denominator on these ones? I don't think so. I don't think common denominator would be beneficial. Well, you know what? When I'm not inspired to see something immediately, I just do my little sines and cosines trick. So, do I want to do that? Yeah, let's do it. Okay, so cosine of x over, and then that's a quotient identity. That's another one, quotient identity. Okay, so this turns into 1 minus sine of x over cosine of x. And then on the other one, that would be 1 minus cosine of x over sine of x. And then I bet, I bet this is probably 5-star just because of the steps that you got to do, because this one might be kind of a little bit weird because you got to work with this fraction, and then combine them. So I don't know. Let's see what we get. So multiply this by the numerator over here, so that like the denominator over here. I'm sorry. So that's going to be multiplied times cosine over cosine. This one's going to be multiplying by sine over sine. So then when we do this one, we get cosine of x over, and that'd be cosine of x minus sine of x over cosine of x, yeah. And then the other fraction is sine of x in the numerator, and then that's going to be sine of x minus cosine of x over sine of x. Okay. Oh, I see why. Okay, I see why this is a 5-star problem. It's because of the difference of these guys, because that's going to end up being the denominator. Anyways, all right, so we multiply this by the reciprocal here, so cosine of x times cosine of x over cosine of x minus sine of x. And then this one's going to be plus sine of x times the reciprocal sine of x over sine of x minus cosine of x. So, you multiply those numerators together. So what do we get? We get cosine squared of x over cosine of x minus sine of x plus sine squared of x over, and I'm going to write this in a little lightly because I'm going to change it a little bit, sine of x minus cosine of x. So, it'd be really cool if I could combine these two, the like terms together, right? But I can't, because the denominators aren't, the same. So to get the denominators the same, if you look closely, we got a cosine, we got a sine, but the signs are different on them. Like this cosine is positive, this one's negative, this one's negative, this one's positive. So to turn this denominator into this denominator, what I would do is multiply this by a -1. So this will turn into a negative, then this will turn into a negative, and this will turn into a positive. And now we do have the same denominator. See, cosine minus sine. So I'm just going to rewrite it like that. So that's the thing that makes it 5 stars, probably. Just that little part of it. We'll end the next part because we're going to have to factor this in a second. But so combining this into one fraction, we end up with, let's see here, cosine squared of x minus sine squared of x over cosine of x minus sine of x. Oh yeah, because when we factor that, that's when we'll get that. Okay, so let's factor the top part, cosine squared minus sine squared. That's a difference of squares, so that'll be cosine of x plus sine of x times cosine of x minus sine of x, all over, and then we've got that cosine of x minus sine of x. So then the numerator and denominator cancel out, and then you're left with the answer that you wanted, cosine of x plus sine of x. Ooh, boy. Yeah, that completes it. So what identities did we do? We only did the quotient identities at the beginning. Man, oh man. That's crazy. All right, 14, the last of the 5-star problems. So let's see here. We got a cosecant and a cosine. It's supposed to be tangent plus cotangent. Okay. Let's see. How can we do that one? Geez. Cosecant over cosine. Then get tangent plus cotangent. I wonder if this is another identity or something, like one of those weird identity things. Let's see. So I don't know. Why don't I try my little? I'll try. I might have. This is one where I might have to erase it and go back and work on it a little bit more. But let's see. Cosecant. I know that's 1 over sine. That's a reciprocal identity. Over cosine. Okay. So then these two won't, because when you have 1/2 over 4, like the denominators multiply together. The same thing's gonna be true here. So like this turns into 1 over sine of x cosine of x. Okay. Then what? How can we turn that into tangent plus cotangent? Maybe we do another one of those identity tricks. Yeah, all right, so let's see. So 1 is the same as sine squared plus cosine squared. So maybe we can use that. Yeah, let's try that, because like since all I have is this 1, I'm gonna try it out and like just see what happens. Okay, because you know I saw that I had a sine and a cosine. I don't know what to do, and I've got addition, so I don't know. Try it out. So 1, let's turn that into sine squared of x plus cosine squared of x over sine of x cosine of x. Oh man, that did it. Holy crap. Okay, so that's Pythagorean identity. Okay, now we're gonna split these two fractions apart. So remember, this is just one number, so it's like sine squared of x over sine of x cosine of x. So it's so weird. It like started out real simple, and it's like ballooning up all of a sudden. Okay, so sine squared over sine cosine plus, and then that's going to be cosine squared over sine of x cosine of x. And then watch this. One of the sines will cancel out here, leaving us with sine of x over cosine of x, or tangent, plus, and then one of the cosines will cancel out here, so we have cosine of x over sine of x. That's brutal. Man, those ones are crazy. All right, so this is a quotient identity, and that's a quotient identity. So we've got tangent from that, and cotangent from that. Goodness gracious. Oh, there's our answer. Wow. So, yeah, these ones where you use 1, that's pretty crazy. That's probably why these are the 5-star ones, just because it's not like something that's immediately apparent, I guess. All right, so that's the second half of this worksheet, and that concludes the whole thing. That's a good chunk of problems that we've covered. How many is that? 16, and then another 14, 30 problems. Okay, so hopefully that's enough practice for you. A couple of good chunk of examples that have been worked out for you. And of course, you know, the level of difficulty you can expect on the quiz or on the test, as always, is probably like the 1 and 2 and 3 star problems, like maybe a 4 or a 5 for like an extra credit type of thing. But yeah, that's it. So if you need any additional help, you know, just reach out to your teacher, and I'm sure they'll help you out before the quiz. And, you know, obviously practice more problems. Use your textbook. They have a bunch of these in the trig identities section. And use your identity worksheet as you're practicing some more problems. Okay, that's it. Hope you enjoyed the video. Good luck on your quiz. And that's about it. Bye-bye.